Okay, so the big thing is I want you guys to think, if we're going to graph these, this is easier than the other lesson. How could we, do this? And the thing is, first of all, we know that absolute value, so it's going to look like a V. Okay, so it's the children of an absolute value functions. And we're going to make a table of values. And so I think the big thing is, how do you know what to pick to make this be true? And I'll teach you kind of a shortcut as we move forward. And so, if I had time, I would have you guys before class started say, can you make a table of values and can you graph some of these functions? And so we'll see, if we had time to do that. And I think if you graph y equals the absolute value of x, and I think I would say graph y equals x, and then graph y is equal to x squared, okay, can you graph those three functions? And I think, because these are the parents of lots of children, okay? And so if you know what the parents look like, you're going to be better off when you try to graph the children, okay? So do you know what these look like? And as I asked, one of my classes today to do this on the board, people first tried the one in the middle, y equals x. And I'm like, how would we do that? Well, that's the copycat function where y will equal what x is. They copy each other. And so if you plug in 0, you're going to get 0. If you plug in 1, you're going to get 1. So y is equal to what x is. So you plug in 2, you get 2. But what if you do negatives? Well, plug in -1, you also get -1. So this function will be graphed like this. It's a line, okay? The second graph that I ask people to do is y equals x squared. Okay, so you take x and you square it. So start with 0. When you square it, you get 0. What happens if you plug in 1? Well, 1 squared, to get y, you get x squared, and you get 1. 2 squared is 4. What if you plug in -1? Put it in parentheses. Take -1 times -1, you get 1. If you plug in -2, -2 times -2 gives us 4. So our graph will look like a U-shaped graph. It's called a parabola, as you guys know. If you squared 2, you get 4. If you went to 3, you'd go up to 9. But that's what that graph will look like. And so everything that's just plain x squareds or has x squared in it is going to look like a U. Now, for an absolute value, let's try it. You plug in x values and you take their absolute value. And I heard people talking today about, like, what does absolute value mean? It means distance from 0. So if you plug in 0, the absolute value of 0 is 0, because if you're standing at 0 on a number line, you're really 0 steps from the origin. If you plug in 1, you get 1. If you plug in 2, stand at 2 on a number line, you're 2 steps from the origin. If you plug in -1, how many steps is -1 from the origin? Let's see. I'm sorry, I got that wrong. And then plug in -2, you also get 2. So if you graph these, and I believe that you graph these as freshmen in Algebra 1, you're going to get a V-shaped. Mine looks curved, but it should be straight with a slope of up 1 and over 1 to the right, and up 1 and left 1 to the left. And that's what the graph of absolute values will look like V. So when we look at our notes for today, you see the absolute values, you're like, well, they're going to look like V's. And so as you plug in these values, you expect that you're going to get V's. And so let's start at 0. Okay, do half of 0 and then take the absolute value. Half of 0 is 0. The absolute value of 0 is 0, okay, because 0 is 0 steps away from the origin. And 0 plus 3 is 3. Oops, I better get a marker. Okay. So I'm going to do 3. I don't know why this is not working. There it is. Okay. And if you plug in 2, okay, let's go pause it. Let's go plug in 2. Half of it is 1. The absolute value of 1 is 1. And then you add 3 to it, and you're going to get 4. And then somebody says, like, well, does that mean that this is going to echo it on the left of it? Well, let's try it. We'll take half of -2, you get -1. Take the absolute value of it, it's 1. And 1 plus 3 makes 4. How are you doing so far? Okay, we're going to get a V, so let's plug in these values. And then if you plug in 4, half of 4 is 2, the absolute value of 2 is 2, and 2 and 3 make 5. Half times -4 is -2, absolute value is 2. Add 3, you get 5. So when you graph these values, you're going to get a V. Okay, and as we do more of these, you're going to notice, what does the 3 do to my graph? If the original function is at the origin, what does the plus 3 do to the vertex of this graph? Well, it goes up 3. Okay, so we're going to see that there's different things that happen. The domain is left to right, negative infinity to positive infinity. And the range is from what? Low to high, 3 to infinity. How are we doing? Check with your neighbors, see if they got any questions. You can always rewatch this if you need to. I think the other thing is, okay, when we go to the back, I ask my students to say, well, see if you can do this. Now, the thing is, you can any values for x to plug it into your function, but the smartest thing to do is to plug in the middle value. And how you find the middle value of the v is to figure out what x values make inside the absolute value to 0. So what would you have to pick for x so that in the absolute value will be 0? Because that'll be the turning point, the v part of your graph. And so see, if you plug in -1, that makes inside the absolute value to 0. That's going to be your middle. So plug in -1 as your value, and then just pick x values to each side of it, and you're going to get your shape pretty lickety split. Now, it doesn't matter if you don't do it exactly that way. However, that will help you be most efficient. Okay, so if you plug in -2 and -3 on each side and 0 and 1 on the other side, you should get your v pretty quick. Okay, so let's try -1. So -1 plus 1 is 0 inside the absolute value, and you get a 0, and you take the absolute value of 0 and it's 0, and then you by the coefficient of -2, so -2 times 0 is 0, and then you plus 3, you get 3. Okay, so if we pick an x value for the middle so that it makes the absolute value part 0, you're going to be real happy you did. So let's plug in 0. 0 plus 1 is going to be 0, it's going to be 1. Take the absolute value of 1, you get 1. And 1 times -2 is -2. And then you add 3 to it, and you get 1. Let's try -2. -2 plus 1 is -1. -1 absolute value is going to be 1. You times it by -2 here. You get -2. So -2 and 3 give us a -1 as well. Pause a second. I'm getting a different answer. Let's check this out. Oh, -2 plus 3 is going to give you 1. Okay, if you don't get symmetry, either you botched something or you didn't find the middle. Okay, so you should get the symmetry if you pick the x value that makes the middle value 0. Okay, so again, you can you can check yourself. Try 1. 1 plus 1 is 2. The absolute value of 2 is 2, and then 2 times -2 is -4, and -4 plus 3 makes -1. Okay, good. Now try -3. 3 plus 1 is -2. -2 absolute value is going to be 2 times -2 is -4, and -4 plus 3 is -1. So we do get that symmetry if you plug in those x values. You can pick any values for x because the domain is any real numbers. But if you want to see the symmetry right quick, finding the middle is going to help you. So -1 goes to 3. -2 goes to 1. I can't see what I'm doing here. -2 goes to 1. 0, -2 goes to 1, 0 goes to 1, 1 goes to -1. I am not plotting this correctly. I need to zoom in just a minute. Let me zoom in so I can see what I'm doing. Okay, here we go. Let's plot this like a good person. Okay, here we go. So let's try this again. -1 goes to 3. She's up here. Okay, good. And then 0 goes to 1. That's right here. I'm plotting in blue now because I really botched this. 1 goes to -1. You go to -2. You get to 1. And then -3 is -1. Now notice we're going to get a V shape. The domain is absolutely -infinity to positive infinity. That's how far it goes left to right. The range is from -infinity, low to high, up to 3 and including 3. And notice, look at this coefficient in front of it. Just like in front of a parabola, if it's grumpy in front of the x squared, you're going to make a grumpy opposite value as well. So just heads up on that. Okay, and then let's keep checking. Okay, let's do this one. Pick the x value so that the opposite value is 0. So what would you have to pick for that? You have to pick 1, wouldn't you? So you pick 1, and then this should be the middle, because 1 minus 1 is 0. Opposite value of 0 is 0, plus 3 is 3. If you plug in values to the right and left of this, you should get the symmetry you're looking for. So try 0. 0 minus 1 is -1. Absolute value of -1 is positive 1. And positive 1 plus 3 is 4. Try 2. 2 minus 1 is 1. Absolute value of 1 is 1. And 1 and 3 make 4. try 3. 3 minus 1 is 2. The opposite value of 2 is 2, and 2 plus 3 makes 5. Plug in -1, you get -1 and -1 is -2. The opposite value of -2 is 2, and 2 and 3 make 5. So we're going to get this opposite value starts at 1, 3, and you can plot the other points, and you're going to get negative infinity to positive infinity for the domain. And for the range, you're going to get from 3 to infinity. Now I'm going to teach you guys how to see, based on this function's equation here, can you tell what the graph is going to look like without having to make a whole table? And so that's something that we're going to learn on Friday. So your homework tonight is going to be on Delta Math. So try your best on these. Some is review, some is plotting points, some is making, doing, the piecewise functions. And it's pretty cool. You can watch the videos. You can look and see if you've got any questions about how to use the material, but it's a pretty neat system. All right. Thank you. Have a good day.